We have one more aspect of our program, and I'd like to invite all of our scientific experts to come and take one of the seats here. I'll take the one on the end, just because it'll be easier than going back and forth like a tennis match. So if you all just come and take a seat there. Now, for our for our overseas guests, there's a really popular program here in Australia called Q&A, and all our Aussies know about it. So this is Q&A, everybody. So it is a democratic forum, and that means for our international visitors, Q&A is a show on the ABC, and it's an opportunity to hear from experts on a topic. In this case, it's genetic epilepsy. And the thing that makes Q&A really special and makes Australia love Q&A is that people in the audience have an opportunity to ask questions as well. So that's really my vision for this conversation. And we know that we have visitors who are joining us, and I wanted to mention because somebody asked me to, and so I'm going to. Nina and Kia from Sydney. Welcome. We're really glad that you're here. So I think if you have a question, I want you to raise your hand. We'll have one of our roving microphones come around to you. And you've got the mic, so that was, risky. You're getting the first question. And I'm sorry, I've tried to track you down a bunch of times. What was the thing you talked about that started with a U in your talk?
Uridine.
How do you say uridine?
Uridine. It's
okay.
Specific. It's a very specific approach to treating that very specific disorder because the children with those variants can't make that particular product.
There were a couple, there have been many things today that have been filled with hope and exciting and kind of that scientific sense of a eureka moment where you look at something, you don't think you have any ability to help, and suddenly you've got something that actually makes a dramatic difference. So are there, obviously, we want to be careful to have that wonderful balance of hope and practicality. I don't want to be too practical because I'm really a hopeful, optimistic person. But with substances like that, how do we have that hunt? How do we look for the next uridine? How do we look, Glenn, how do we look for the next spider venom? Who comes up with this stuff? So that's just one question.
So a lot of it comes down to what I think it was Gavin who said, we need to find the genes first, and a lot of our time, Ingrid and mine and our colleagues have been spent trying to find the genes, and that's been extremely gratifying and continues to go on, and that's something that many of us were told early in our careers, well, that's not genetic, so stop trying, and why don't you work on something else instead? So that's just one step in a 100-step path towards trying to find what might work. The next step really is figuring out where is that gene expressed, what does it make? Let's understand the biology, and so when we're lucky, and we're never lucky in this situation, but the luckiest we might be is if we actually stumble upon a biochemical pathway that's not only something that we've heard of, but something that people have been studying for a long time. And so that's where this uridine falls in. It's a pyrimidine synthesis pathway. The pyrimidines are these basic, pyrimidines and purines are our ATGC of DNA. So they've been studied as long as we've known about DNA, and this particular pathway is something that's actually not well outlined in the textbook that I bought, but in the updated version of that textbook, which my colleague down the hall had, the pathway was well worked out, and you could look at that and say, gee, if that step's broken and I can't make this, can I just give this, or can I find another way to get to this? And if this is something you can buy at a health food store that's safe and quasi-regulated in the US, then, is there any harm in giving a try? The only thing I would say to that is I think from a medical perspective, you're weighing risks and benefits. There's not a harm in giving it a try, but is there a harm in doing it over and over again in an N of 1 fashion? Several of us have talked about this. We'd really rather do it in an organized clinical trial if we can get enough people together so we can really generalize the information.
All right. I know, Ingrid, I was speaking to you before, and we were talking about there have been so many aspects that we have discussed, but enzymes, we haven't really talked about. There's a whole other area that we really haven't mentioned. Can you talk a little bit about that, just because I want to make sure that everybody who's here today has a sense of really the range of different paths that we're studying?
Well, I think what I was referring to is that sort of along the same lines that Anne was just talking about, that when you actually have a gene defect that leads to you don't make a specific protein, one approach that isn't as technically I suppose, demanding in terms of developing something new or finding something that exists that you didn't know about, would be to actually make the enzyme that's missing and replace it. And that's just one thing that's worked, and we were talking in the context of Batten disease, or neuronal ceroid lipofuscinosis is the proper name, and the gene is SCLN2, and like the Spinraza story, different replacement or different way of fixing the problem, but children with that need fortnightly infusions into the spinal cord area, or the little boy that I look after has it through a reservoir on the top of his head, and that's managed to stop progression of a fatal disease. So, you know, these disorders we're talking about today have an increased mortality, and Dravet syndrome as the poster child is about 15% by 20 years of age. Some of the more severe epilepsies are higher than that, but this other disorder with the enzyme replacement therapy is 100% by about 10, I think. 6 to 10 years of age. So it's, if you will, worse, if that's possible. And these children, they've now got this drug that you inject fortnightly to replace what's not being made. So just another approach.
Well, while we're on that subject of drugs being injected and pumps and the like, because that was one of our kind of last treatments that we heard about, or potential treatments that we were hearing about from Glenn and Steve, it's very exciting, but I also know it's complicated, isn't it? Because there's the scientific piece, the research piece, the lab piece, and then there's getting it actually into the patient population. So I would love to hear from you and Anne about that element of, oh, that was interesting. Did you see that little hot potato move? Yeah. Just want you to know what happened there. But can you, but this is what we all need to understand this. It is complicated, isn't it? There's the scientific and there's also the medical delivery model. And
I'm wondering, Sarah, if you have the kind of hearing that I have, which is that you could hear us from the bottom of the room when we were at the top of the room.
I've got good hearing.
Yeah. So, you know, I think this is a really, really important piece, and I'm glad you asked. And I was actually, you know, I think this day has been incredible, and the interaction has been incredible. The questions have been wonderful, and the excitement is really palpable in terms of what's coming. And as a scientist, I feel that way, but as a doctor, I feel that way, because the status quo in medicine is, you know, people are busy, doctors are busy, you've got to sort of, patients come in, patients come out, and you've got these treatments, and it's not particularly scientific, and it's not very creative. And we've had a whole day hearing about discovery and creative approaches that make scientific sense, and that is extremely exciting. And so what I was saying earlier to Ingrid is the last thing I want to do is rain on the parade, but I think we have to be just practical, as you said, about what this means and the time that it takes. And so, you know, I'll tell you, even to do something as seemingly simple as giving a compound that's already FDA approved in the US, that's already approved for some other indication, to be able to get, you know, sanction and permission from the FDA to do that, and then get permission from my own human subjects board to be able to deliver it with a really perfectly safe compound with a reasonable indication and good science behind it, that can take a year. And so when we're talking about now spinal infusions in kids who already are vulnerable, and new compounds where the safety data aren't available yet, I think it's appropriate to be cautious that it's not going to be tomorrow. But it's also right to be optimistic and say, we've got to keep trying. And so you do the safety data, and you get there, and you take the proof of principle that Glenn and Steve were talking about, and take it to preclinical trials and take it to safety trials, which again is going to be a year or two, but that's the only way we'll get there. So I think we have to be cautious and realistic, but we have to keep trying to get there.
all right, well, let's move, if we can, to Gavin for just a moment here. I'm going to do a little American thing, and I'm going to come over to Steve after that. But from the American angle, you guys you're visiting from overseas, and that's part of what you do as scientists. You travel around and you have that opportunity probably a lot. I think I'm getting that nod, right? Constant jet lag. But it is that opportunity, as great as it is to be connected, there is something that happens when you're in a room together. So when you go back to Florida, what will you take from today? What will you look at differently in your lab? What will you noodle away with based on what's happened here? What questions might you ask, or who might you email based on what has happened here today?
Let me try to unpack that. That's a lot.
And you don't have to answer all of it. That just gives you some starting ground.
Is this how you normally treat Americans? Okay,
Yes,
so.
yes, Yes, it's a different standard. You're American, you can handle it.
So I think what a lot of us try to do is we try to come up with different approaches, and we try not to do the same thing, right? I mean, because it's kind of silly to invest so much of your career like kind of on the same method. So I purposely haven't thought much about RNA-based therapies because as Steve mentioned, I'm more of a vertical person. So I'm trying to try different approaches on the same disorder. But I'm actually very excited about the possibility of RNA-based therapies, and I haven't been reading as much about them as I should. And probably what I'm going to be doing on my 16-hour flight, 3 hours, where maybe I could take a shower, and then my 6-hour flight back to Miami is I'll be, in my baggage, exactly. Yeah, it was my baggage. I'll be reading more about that. I think it's very exciting because it's true. Spinraza is a game changer. So when we were having the SYNGAP meeting that's dedicated specifically to the most cutting edge treatments for rare disorders, so we're having someone from Biogen, the project leader from Spinraza, come to that meeting. We're very excited about that, and so I want to be prepared whenever he comes because I think you're right. I think that there's so that is probably one of the most exciting developments, I think. So.
All right, very interesting. So that takes us, see, I knew it was going to take us to you. So picking up on that, what do you take away from here, and where do you go? Are there any ways in which what you're doing shifts, or are you just going to power on with exactly what you're doing? And how do we help you?
Well, I think one important thing is just meeting Gavin to impact our SYNGAP work, and I'd love to try and collaborate and do this together. And it would be wonderful because it's only going to go fast. In the same way Glenn and I work together and it happened quicker than we could on our own. If you can find the right collaborator and do things together, it would be that's going to be one thing I hope emerges from this. We'll learn a lot. There's a lot about SYNGAP we don't know, and we haven't had discussions about the 5' UTR and the lack of potential in that area for SYNGAP1. But so I think that's important. Everyone else I know, I know I've been working
right.
with
Well, that's the
everyone
point because
in the room already.
So the thing is, the reason why you travel isn't just to see the beautiful city. You got to sit down with people, and you don't want to work with everybody, right? You don't know who you can work with until you meet them, right? I like this guy.
We're really happy that we did this speed dating. We're really happy this speed dating worked, and it's really great.
When I thought I didn't get a box of chocolates, he graciously
I gave you a
me
box
his
of
ones.
chocolates. All right, I was a little late, but I walked around to give you the box of chocolates. Okay, yes. So you shared the box of chocolates,
Yeah.
and now you're going to share the RNA
bromance,
and the
and then we're
vertical.
gonna
The
go-
bromance is happening, and it's happening. Okay. So, but we're being practical and real, and I'm a journalist, so I also have to ask you the tough question, which is the reality is, I mean, you guys are fabulous, and we love you, and you're collaborating, but you also, there's publisher perish, there's, siloing of institutions, big organizations hold on to their stuff for credibility and for money. So how do we break down those barriers? How do we foster what we're seeing here?
Yeah,
To create more opportunities for that to
there's
work
the stuff
well.
you'd like to do in science, and this is my view, not everyone might share this, but there's this whole aspect of just survival. Up
Yeah.
until 3 years ago, my contract was available as long as I got a grant. So I was just going from 3-year period to 3-year period. So I didn't want to get a job as a lecturer and just give lectures all day. I wanted to do research in Australia. If you're going to only do research, you're on what they call soft money. So therefore that puts
And
a
there's
different-
nothing easy, or it's very hard to
it's
have
very hard to
yeah.
get soft money. But living like that, sort of go, well, I could be 100% open, but then if I lose the ability to have great quality papers and all this novelty, that affects your ability to even survive and be around in 3 years to do the next round. And I think the only way to fix that is to improve the careers and the career path and the opportunities for scientists. So that aspect of the equation is not necessarily there. Maybe we still need to be good and be evaluated and make sure we're functional, but it's terrible to think you do everything you can and then at some level there's still a bit of a coin toss element to whether you survive. And it would be good if we could remove that, and then that would break a lot of the barriers. And one final thing, if I rant a bit, sorry, is that our career success is often measured by how we are as individuals. How many grants do you have? How many papers do you have? How many citations have you got? How many times have you been invited to speak? And you could look at it as a very selfish pursuit, because the only way I'm going to survive is being the best individual scientist I can. And that's maybe not the best way to benefit everything. If we have a way of that, we're not being measured solely by that, maybe the way we function in groups should be rewarded and cherished. Like, you know, I've got a large group, 8 of those people could go off and try and get their own labs together. We might be less effective because of that. But that might be the only way they have long-term survival. And that's a pity that we don't value and treasure that sort of thing.
Agreed. Now let's go from that to you, Snez. I'm coming to you last because we just got you last, so we'll go to Snez now. Now, Snez, you bring to this group, I think, another international perspective, which is that as a scientist, you have been following KCNQ2 as it happens for some time. Tell us how that works, and just a little bit about how we can help you help this population when you're migrating from Belgrade to Germany to Melbourne. How do we help make that work better, or can we?
Migrating works actually really well. If you want to migrate, that's easy. So I don't think mobility is the problem in science if you really want that. Problem is to stay somewhere if you like it. So, and the same thing you're saying, it is amazing to see that it's the same in Germany and Europe. There are no long-term contracts that are easy to get, and if you want to do science and not become a professor, which is, maybe you want, but it's not possible for every and each of us, and there are no real scientific careers. I couldn't stay in Germany. I mean, I could on one-year contracts, but it's the same thing, like, I guess here. So it's just, you don't, I mean, I was told that I don't have a killer instinct. And, I know that I could actually, and I'm thinking sometimes, like, yeah, I could work differently. Maybe it would be easier if I had just my own group. But I actually think that my strength is also contributing to the team, and I'm actually really good as a second person in the lab. And I think, I just see that it would be nice that there's more diversity in career paths for scientists, because we all contribute in different ways. And it's not only
And we've seen that today.
Alpha person that is, if Steve would be the only one in the lab, there would be not much to present, I guess.
Yes, you, and then I'll go to Ingrid after that.
I'm going to be controversial again, as
Oh,
I
good,
was
go for
at
it.
KCNQ2. The biggest problem we have here, and this is where I'm appealing to all of the Australian parents, is that we have some of the very best scientists in this field and related fields in the world and are publishing in the very best journals. In contrast, we have one of the lowest levels of R&D investment by the government at the entire OECD countries. Greece invests more percentage of its government funds in research.
Congratulations, Greece, but bad news for us in Australia.
The success rate for funding from the National Health and Medical Research Council at the moment is the lowest ever. So despite the rhetoric from consecutive federal governments, the funding for medical research in Australia at the moment is at an all-time low. So I'd appeal to... Sorry? And not just medical research, yeah. So I'd appeal to all of you to make this point to your local politicians that it needs to be more than just rhetoric. They need to actually put some money into science.
Ingrid, did you want us to add on to that?
I'm not going to go to that same place. I'm going somewhere else, which really hasn't had as much airtime, which is about clinical researchers and clinician scientists. And I know that everyone's got their own barrow to thing, but I think to push. But I think that we need to recognise we need funding also for clinical scientists or clinician scientists. You can't do the sorts of work that Anne and I do without being a paediatric neurologist, and that's only 13 years of training. And then if you want to do academic, that's a PhD. It's sort of another 3 years in there as well. I always joke it was 21 years from starting medical school to submitting my PhD. And I only got a proper job 2 years ago after I won the Australian Prime Minister's Prize for Science. I'm not asking you for a job, I'm just telling you that our situation is not good either. And people say, oh, you can go off and be a doctor, a medical doctor, but while you're a medical doctor, you don't have time for science except at midnight. So we really need to grow clinician scientists, and that's why we have these med students you've been helping today. And you don't have to be a neurologist to do what we do. Amy is as talented as I am, and there are many people that we train from around the world that come to train with us. But I think the plight is much broader than just for the scientists, and I think we really need to work together in teams. I think Steve's point about everyone getting basically, what am I trying to say? Getting the acclaim of the science is important, that we share it as a team and that it's not about first and last. And there's still a really big issue. This is a hobby horse, so I'll say it in one sentence, for women in science and medicine. And we still are well below the men, and that's partly, I think, gender related. So I think there's a big issue
Look
around
how
that
well
as
we've done, by the way, everyone.
Let me add one thing to this. So this issue of funding and who you fund and how you fund is something that's shared by all countries, right? So I think one of the things that we think about is if you're going to fund the research, the only way that's going to happen is if you, as advocates, the families, pound on the door of the people that you can kick out. Okay? And I'm not a political person. And I'll tell you that this actually works. So in America, our politics are in an interesting state. They cannot pass budgets. Okay, so I just got a large grant, right, that was delayed 9 months because they kept passing these continuing resolutions. However, I can say with a straight face that NIH funding, which is $35 billion this year, is bipartisan. It's bipartisan because everybody knows somebody who needs a cure. And one of the reasons why, when they're trying to cut everything, we got a $3 or $4 billion increase, which pushes pay lines up to this 20% line, which is where the innovative science is, by the way. If you get all of your reviewers to agree that it's great, that means it's boring. By definition, you guys know that. If it's a little bit edgy and cutting edge, someone's gonna be like, that guy's crazy. So I think it's important, if you're having trouble in this country and the funding lines are going down, it's actually not the scientists that are going to turn that around, it's the public.
Well, I think you're saying it's also the politicians. It's knock on some doors.
Don't listen to them.
Okay, here's an expression from America, everybody. Throw the bums out. Anyway, just saying. Okay.
But we
yes.
know that some of our parents have been talking to the health minister. Our health minister at the moment is very receptive to families going along, and they've managed to get a grant, which is fantastic.
Can you stand up and say a little bit about that? I think that would be great. Danielle?
Do I need to stand?
Yes, thank you.
So we lobbied and we sat down with Greg Hunt, the health minister, and on the 26th of March this year, we actually got $2 million committed to genetic epilepsy research. And we've actually got honour here from the Epilepsy Foundation. The Epilepsy Foundation are administering the grants. So one grant is for a specific purpose, and that's for SYNGAP, and then $1.5 million for other genetic epilepsies. So clinicians, scientists need to just submit applications and get the rest of that money. So that's amazing.
It's extremely exciting. So when we say throw the bums out, we don't mean everybody. Just make sure you get people who are interested in this important topic. Now, our next question is from India. This is from Abid. Is the PRRT2 gene mutation being researched? Is the PRR2 gene being researched?
It is. And for those who don't know, the gene PRRT2 is a gene that's associated with a wide range of conditions. So it certainly can be associated with infantile convulsions. It can be associated with ataxia, so attacks of loss of balance, and other such conditions. And it is being researched too, but it's also one of those genes where there's been sort of a simple eureka moment. So it turns out that good old carbamazepine or Tegretol actually can work to dampen, if not control, the seizures, prevent some of the ataxia, and there's a movement disorder, paroxysmal dyskinesia movement disorder, that also can be controlled with that. And so there is research being done. It's one of a spectrum of disorders that can have these various features, but it turns out that in many of the children who have it, the treatment is something that we've had on the shelf a long time. So that's sort of a happy story. There's certainly more basic biology going on as well, because even though you may not need to go to great lengths to figure out what to do for treatment today, there's still a lot of neuroscience to be learned, and that can impact other areas of epilepsy and neurological disorders.
Just to add to that, basically it was found for a mild form of familial epilepsy, very mild, and then you can have these movement disorders which are mild. And there's one, I think, Italian paper of 2 mutations, so a recessive picture, which is slightly worse. It's not well recognised in the developmental and epileptic encephalopathies, and I think it has a lot of natural variation. So I think there are quite a few changes being found that are probably not causative. So your clinician needs to be very certain that it is the cause. Would you agree with that?
I would love to ask this next question sort of more openly, because there are a variety. This might be true for any number of you. This is from Kat in Australia. Are there any new research programs being conducted? And how can parents find out about research programs? So obviously this is pretty wide, but do any of you with any of the disabilities, are you actively soliciting patients? Yes, go for it.
So our research group, and many of you have signed up today, I think, at University of Melbourne Epilepsy Research Centre, we now have 17,000 people on our database, of which about half are unaffected parents or whatever, but half are affected, and that's a 25-year program, and that's how we've had so much gene discovery and done all the other work. So we're probably the main portal in Australia for genetic epilepsies. We do have hopes in the future to build a network that is more, well, we love collaborating with everyone around Australia, and if you ask, most of the child neurologists in Australia have been on various of our papers when they have contributed patients to different studies. But this probably will become a little more formalised in the next few years. But I think many of the different genes also have their own registries, and that's what Anne was talking about with PCDH19. We also are very keen to have those cases and to contribute together. SCN2A, we're hoping will be set up from Australia with Catherine Howe when she's back. We're going to have a research assistant doing that. We're very interested in SYNGAP1. So I think there's a lot going on in terms of getting people onto databases, and that's really important in terms of treatments.
All right, I'm going to swing down to the end and then we'll kind of make our way down. Steve, both based on what you've heard here today and also what's going on in your own lab, what gives you the most reason for optimism right now in terms of the state of play with genetic epilepsy, and what worries you the most?
I think what the optimism is that there is so many interdisciplinary efforts all focused around trying to make things work, from clinical to technical to research to large company to regulatory bodies. Now that's fantastic. I think the thing that scares me is that 5 years from now, we're still having this conversation and we haven't delivered anything, and then people's patience at all levels will wear out. So what keeps me up at night is how to deliver. And we have to deliver, there's some programs we got that are way more advanced, and I think getting some more wins, having our Spinraza moment for genetic epilepsy is going to be critical. And that needs to happen, I think, sooner rather than later. Despite the challenges, we have to know how to overcome them. We think we've got good approaches for doing the tox and all the regulatory things so that we can move. But I think there's an opportunity because everything's a perfect storm. There's the threat of non-performance.
All right, let me bring it on down. I'm going to go right down the line on that question. What's the most exciting thing for you right now? You're looking broadly at genetic epilepsies, and where are you concerned?
Maybe I'll start with the concern so I can end with optimism. I have the same concern that Steve does, which is that we've been really galvanized as a community and talking about the promise of genetic epilepsies and how that's really going to get us to precision medicine. And I do think, especially when I see the same patients year after year, and we've talked about this for several years, and we don't have the cure yet, that people's patience is wearing thin. And so I think that's my concern, is that we're not moving fast enough, and if it feels that way for us, that it feels that way times 1,000 for all of you. But my optimism sort of lies in the same area, which is that we are working together. A lot of our gene discovery is now through a communal group of institutions working together. Our functional data is being shared across platforms, and as much as we do live in this academic world where we do have to have a certain number of first and last author papers, for many of us that can be part of our profile, but the other parts of our profile can be, okay, I'm going to work on this gene, I'm going to work on this aspect, and if I'm going to do this in the zebrafish and you're doing it in the iPSCs and you're doing it in the mouse, we're going to compare across platforms and really have a whole rich conversation rather than 5 separate conversations. And I think if we can achieve that for all of the genes we've talked about and really make that the new way to do science, that then we'll achieve something.
So we're looking at basically creating a new model for how we do this.
A new model of sharing. You
New model
know,
of
the science has been great. I mean, people have been doing the science for years. Have
Oh,
been
we're
doing
all
great
about
deep
the
science.
sharing.
Yeah,
We're
but
with you
it's-
on that. Let's go to Gavin.
What makes me optimistic is also scares me. So I think what makes me most optimistic is I think being a neurobiologist or even a clinician who dabbles in neuroscience or does neuroscience for translation, the tools that are emerging and the technology is exploding, and it's centered a lot around the brain. So brain initiatives are happening in all major countries. I don't know if Australia has a similar, but and we're talking billions of dollars in aggregate. And a lot of that now is being used in rodent models, but most of the calls in the US are around being able to measure brain activity in the human brain. So that is extraordinarily exciting, okay? Because we need to use those in patients. Now that same thing scares me. So the more I learn about the brain, the more I understand how little we know. And that's what scares me. So that's where things like Spinraza, we have to really rally around those successes. Because I think there will be some ground ball singles and there will be some, maybe even some home runs. But at the same time, I'm not so sure we can expect that for every single gene disorder, because some of them will turn out to be infinitely complex and some of them will be, you know, maybe pretty simple. So the sodium channel disorders, I have a lot of optimism that they may be somewhat simple in the sense that there's, if you correct the channel function, you may actually get a lot of improvement. But other disorders where the protein may have, or the gene may have multiple functions that we don't even know half of the lives they live, that scares me.
Very interesting. All right, Ingrid?
Well, I think my colleagues have really said it beautifully already. What else can I add? I'm very excited, both by the spiders, which I hate, and the antisense oligonucleotides, the RNA work. I think they're just fabulous. But I'm also worried for you about the roller coaster of vulnerability, I call it, where each new drug, is that the saving grace? Is that going to make my child fine? Will I get rid of these seizures? Will they develop? And then, boy, it doesn't work. And then we try cannabidiol, and boy, it doesn't work. And then we try this one, and every one is a new bit of this roller coaster. And I try and think, how can I protect you so that you won't suffer as much as a family, but maintain hope? And I think that's really hard. To not, you know, you walk out of here, you want that injection in your child's back tomorrow, you want his ASO, and you want your child to be normal. And is that realism? So that's my, the thing I'm struggling with, I guess. You know, not only do we have these whiz-bang promising drugs, but they have to be given to the child at the right age. And that might be in utero, before you know your child has a problem, because maybe the development's already impacted. It has to get to the right cells in the brain. If it goes to the wrong cells, it may do nothing, it may not help. It has to be given in a safe route. So intrathecal now, you know, as I said, this little boy's getting it this every fortnight, and he's fine. But you get one injection wrong with bacteria, you have meningitis, you can die. These are big deals. So that's the bit that worries me. How can I get it to you as fast as possible, as safe as possible, and that we can really know it makes a difference and isn't, you know, got other reasons for being successful. But having said all that, I don't sound optimistic, but I am optimistic. That's why I'm here.
We're a lot further along than we were 5 years, 10 years, 20 years ago. All right, Snez?
Yeah, what makes me optimistic are meetings like this. I think we've never been exposed in science as much to really what happens in the real world. And we heard that also here, that, you know, we kind of saw genes and variants, but now we see kids. And I think that this also puts a lot more responsibility on what we are doing. What does worry me a bit is that we feel the urgency, but we also know that experiments don't always work, and that sometimes they take a lot of time to establish and make them work. And, you know, finding that fine balance is also, yeah, something we have to work on, I guess.
And scientists have families too. Yes? Go ahead, Glenn.
I'm, like Gavin, very optimistic about the ion channelopathy epilepsies for several reasons. While we know still don't know, have a full understanding. Our understanding of ion channels over the last decade has just been an explosive growth in knowledge, to the point where ion channels are now the third largest class of human drugs.
Can I ask
Can
a
you
question
believe that?
about that quickly? Is that because of the specifics of the ion channel? Or is that in part because Dravet was diagnosed quite a few years ago and there's been so much attention and research? Is it, you're saying no, Gavin?
No, I think it's because we just understand the role
You
of ion
just
channels in
understand it
many
better. Okay.
diseases, and we've
Okay.
learned how to target them with drugs much better than
Okay.
we could 10 years ago. So our ability to target these ion channels is much greater than it was 10 years ago. And there's, as Steve's shown, there's many different options for targeting these ion channels. So I'm super optimistic about that. I think we will have new drugs for some of these ion channelopathies. What I did want to say, though, is we work, and this is the thing that worries me most, because we work on a number of diseases that affect some of the most impoverished countries in the world, and therefore the cost of drugs is a big concern to us. And this new drug, what is it? Spinraza. I mean, that's just untenable. We can't afford to be paying that sort of money for anti-epileptic drugs. So something has to change in the landscape to make these things affordable for patients, for families. And I'm not sure what that is, but it's untenable going forward.
All right, stay with that for just a moment. I just have a couple things from our live stream. Bella from Sydney says hi to her mom, who is here in the audience. Who is here? Bella's mom. Who are you? She might be downstairs. Anyway, well, hi to Bella's mom. Oh, is that Bella's mom? Raise your hand, Bella's mom. Yay, congratulations. Chris from Australia, SCN9A missense de novo in a child with continuous spike wave syndrome, but told SCN9A is not causative or contributive. Is this because research hasn't been done? Is this because research hasn't been done? Is it because Ingrid knows all answers? Or is it, I'm sorry, that part wasn't in here. Or is it more complex?
It's more complex.
And we'll allow you to elaborate just a little bit.
So
Is that
I'll
tricky?
elaborate in just quickly, but SCN9A was found in one big family with genetic epilepsy with febrile seizures plus, a mild disorder, and it was talked about as a modifier gene for Dravet. I'm not sure I believe that particularly. I don't think it was strong, and I think SCN9A is still up there and unsolved at the moment, and Anne's nodding. Can I hijack it just to say one other comment? Because I said this to a few of the parents today, but I just wanted to make a comment that there are a number of gene patients with genes that are not, the groups are not represented here. And I just wanted to alert the rest of you to this, and that's because these genes are inherited from their parents, and the parents are often mildly affected enough to have their own families, but that means they're not bright parents who can make it to an event like this or follow an event like this. And so those genes are, if you like, not getting enough love and attention because they don't have you guys. And, you know, you need bright, committed parents who have enough wherewithal, apart from looking after a sick child, to make it to something like this, to be able to look at Dr. Google and all these things. And I just wanted to point out that, you know, I have families with some of these genes, and those families are not as resourceful. So there's another whole ocean out there that's being underrepresented.
So basically, we have cousins who aren't here.
Exactly.
Yes, the rest of the family. May I pause for a second? Yes, I was going to say I want to take questions from the audience, so we'll start with you. Yes.
More of a statement than a question for you, Ingrid. Your fears about you guys not giving us what we need, I think the opposite also applies. We demand a lot from you guys, and we expect you to give us those miracles to make our kids normal. And we know that's not going to happen because, you know, normal is not always the best medicine. For us, I guess, what we need from you is open, honest communication. We don't want the sugar-coated solutions. We want the cold, hard truth so that we can deal with it. We are very resilient as parents of these kids. Our kids are very resilient, and this is our normal. A lot of people say to me specifically, I don't know how you do it, and all the usual, you know, comments and whatever that, you know, they think we're suffering somehow. But people in this room are the ones with the power, and we're the ones that are going to make a difference with your support and with the information that we're gathering through these forums to actually make a difference in our kids' lives. So it's as much about you, more about you guys than it is about us. But it's definitely a partnership and a journey that we're all on together. So, yeah, don't beat yourselves up that you're not doing enough for us. I think it's a two-way street.
All right. Very good. We have a question on the front row, please.
I'd like to ask a bit about Lennox-Gaunt. Is there any research being done into that?
The question for our live stream audience, Lennox-Gaunt.
Do you mean Lennox-Gastaut?
Lennox-Gastaut.
Yeah, I think so. So that is one of the syndromes that I showed in my talk, of which there are many syndromes. And yes, there's a huge amount of research being done in that. And there are probably, 30 or 40 genes already for Lennox-Gastaut, of which there are a number of the genes we've heard about today can cause Lennox-Gastaut. So there's lots of research. But it's a whole group of different genetic diseases. And there are a lot more to solve as well. Oh, Lennox-Gastaut. So the question was, do I believe it with a fourth generation foster child who's fourth generation of epilepsy? So there's two answers to that. One, the first answer is that there is a gene running through your family, through your foster child's family, that the foster child has inherited that's causing their disease. The problem with that is many children and adults, in fact, with Lennox-Gastaut syndrome have significant intellectual disability, and they won't have their own children because they're too intellectually disabled. So it could be that that gene abnormality has got worse in some way through the generations, or more likely that they have an additional new gene change in them that's caused it. If it was just 2 generations, it could be the story about the mosaicism that I mentioned earlier.
All right, I'm going to allow one more. Yep, we've got a couple more questions. Yes, one here, please. And then, did you? Okay, next.
I also just wanted to respond to what Ingrid said. I often have doctors worried that my hope's going to get up too high and that's somehow going to injure me if I try something new, like, cannabis oil. And I just want to reassure you all that it's so much nicer being able to try something, even if you know it's not going to work, or even if it doesn't work. Getting your hope up doesn't hurt us, it helps us. And really, I'd much rather spend my time hoping and then being disappointed than sitting there doing nothing to help my child.
I agree with that too.
It's a very good point.
It really is. Hope is a wonderful thing. It keeps us going.
All right, we have a couple more. Yes. And Danny, when we come, I've skipped somebody in the front row. After you, my friend. Go right ahead, please.
I'm following on from that same topic with regards to hope. I'm wondering how we can hear about the research and what's around the corner that is going to help. My son has a disorder that isn't actually represented or talked about. He's too rare, but I'm always hopeful that I might hear of something that I can then somehow generate some interest to start something. But we need that hope for what's coming up shortly, and hearing about the great successes with different things with Dravet and Casey and the various disorders. It does motivate me to keep up hope, and knowing that there's stuff that might not happen for 10 or 20 years for some of these disorders, and this amazing research, cutting edge research, is inspirational, but it also helps drive us to find out what's coming up. And it's really hard to get that information. We're not the clinicians that are reading the research papers, and how do we access?
Monica knows more about the literature than I do. So in a certain aspect of the literature, she's more well-informed because I have to read certain types of literature. But what I've learned is the parents, or especially the parents that are here, are voracious readers. and they share. So my advice to you would be to read these. You know, Monica's got a blog, she's got Facebook pages, there's dozens of patient support groups. And I would say that's a very good resource for what's very current, especially as it relates to new therapies.
And I think you should chat to Monica as well. I'm just saying because she'll give you suggestions from what she's done. Like, in other words, feel free to extrapolate and to copy the strategies that people who have had a rare disorder have used to find other people, because finding people who are connected can be extremely helpful. Kelly, I'm going to come to you, but I've got somebody at the front who have passed over.
Thank you very much.
You're welcome. Sorry.
My daughter Abigail's 9, and we've got to genome sequencing and still have no questions. She's the $1 million question mark girl. How often can you revisit this? If she's in databases, does it naturally happen? Is this something that I need to agitate every couple of years and go, can somebody else look at this data? She's considered Lennox-Gastaut. We've tried every medication. The next thing is vagal nerve stimulation. So help.
I would say yes, yes, and yes. And so, you know, the technology has really raced very quickly, almost ahead of itself, such that, especially with whole genome, as Ingrid was saying, we can generate data on all of the genes, the exons and the introns, but we don't necessarily know how to interpret all of the data. And so whether it's a panel or an exome or a genome, it's vitally important that the data get looked at on a recurring basis, because we learn new things about neuroscience, we learn new things about genes that you would look at a variant and say, oh, that can't be anything, that gene's a cancer gene. We later found out is not. And so how does that happen is an important question. How it happened until recently, I'll speak for the US and pass it to you, but it's probably similar, is patients would come back and they'd be, you know, there for their routine visit, and we'd be doing the meds and say, hey, by the way, you know, did we ever get your results back? No, let's take a look at them. And then we'd dredge up the data and take a look at it ourselves. So being in a clinical setting that's partnered with a research setting like you have here in Australia and like some of us have in the US is really important, because, you know, no one of us can do anything. And if I'm sitting there in clinic at 2 o'clock, there's no way by 5 o'clock somebody can analyze it. So we've set up a system where we go through the whole list of who's coming in tomorrow on Monday. And everybody who's unsolved, we've got somebody who's going to go back and look, or call the clinical lab and have everything reanalyzed, because we've gotten behind just because things are going so fast. And so it really takes a proactive approach on our part. I'm in a very privileged setting where I'm with other physicians whom I've trained, genetic counselors, you know, and I'm mostly in the lab, and so I'm not sort of in the clinic busy all the time, and so I can have a little more time to think about things like that. My other clinician colleagues are not in that situation. They're in clinic 5 days a week and don't have time to look these things up. And I think that applies to most of the neurologists we know. So there's a very active role that you can take. I'm not worried about you all, because you're going to ask, and we have repositories where there is every 6 month relook through an NIH-funded study, for example, where it is automatic if you sign up for that study called the Epilepsy Genetics Initiative. I'm worried about all my other patients who can barely make it to the visits in the first place, and it took us 3 years to get the insurance approval, to get the testing, and then 2 years go by before we catch up with them again, and they're not going to call me and ask, and you know, I'm not going to remember every single one of them. And so I think that's what I worry about a little bit more. So there has to be, in medicine in general, a more systematic approach to this. The cancer folks do it a little bit more proactively because it's cancer. And I think we have to sort of adopt the philosophy that it doesn't have to be cancer to be taken seriously.
All right, we have a question here. Yes, go right ahead, and then we'll go.
Quick Australian perspective on that. If your testing has been done clinically, it won't be looked at again. And if that's the case, then if you're happy to come on board with our research program, once we have your consent, of course, we pull in the data, and then it will go to our iterative pipeline, which is exactly what Anne's doing, but it's done by, at the moment, it's done in Australia and in Seattle, both, isn't it? But if you're staying just in the commercial world, no one will look at it again. So you do need to bring it into a research domain. And we're interested because we want to solve all the unsolved ones. And it's not, because it's a genome, it's particularly intriguing because there may be different types of mutations that are unknown, but tomorrow we'll know.
All right. We have a question here, and then we can go up to you. Yes.
Sorry, just I missed your name before, but before Solomon only got diagnosed in December last year, and I belong to a group called SWAN, which is Syndromes Without a Name. So it's a support group, and they were the ones that got me assistance to get the exome sequencing done. And I still belong to that group now, even though we do have a diagnosis. But they do a lot of advocacy and keep you up to date with a lot of the recent developments in the literature, and it's worth becoming a part of the group so you're not alone. There's a lot of resources there, just regardless of how unique your situation is.
And Kelly?
I'm not an advocate for the Epilepsy Foundation. I'm just reminding everybody that the Epilepsy Foundation is there for you guys. Make them work. Get them. I know, that's why I said I'm not an advocate for them. They are great. I think they're getting... There was a period of not so goodness, but just make them work for you. Get onto them. Each state, if you can't get onto your own state, get onto the one in Victoria. It seems to be the largest. Get them working for you guys. Don't take no for an answer or I can't find it. That's what they're there for. That's what we do Purple Day for. Don't forget to, if you're not sure of groups or support groups, ring them, get onto somebody and say, I need help, I need support, I need to speak to somebody else who's suffering the way I am. And if they can't help you, ask them to get you to the next step. And even if you speak, if you're undiagnosed and they think along the lines of Dravet or whatever, just get onto that group. Get the support. There was nothing for a long, long time, and the last 7, 8 years has got so much better. Make them work for you guys. That's what they're there for, and that's what you guys raise money for regularly, every year. And don't let them put you off. Just keep on ringing them.
All right. Persistence definitely can carry the day. Let me pause. Do we have any more questions? One here. Did you have one as well? You're right there. So go there, and then we'll come to you.
Really quick, it's not a question, it's actually an expression of gratitude. So we're all here as, cousins and family members, and so what you do benefits all of us as a whole, but it's also personal. So the work that each and every one of you do actually affects me personally and my daughter personally, so I just wanted to say thank you and keep going.
Great. We'll come over. Well put.
Hi, it's great that we're identifying the genes and possible treatments. I'm just wondering whether there's any research going into identifying why, for the conditions where it's a mutation, is there research going in looking back and saying, well, why are these mutations occurring? Is there common themes with families? So is there work going into that as well?
I mean, mutations are a natural part of any animal. So there's the reason evolution is driven by a specific mutation rate, and a lot of mutations make us adapt to different environments, and that's why animals evolved, and it goes back to lots of basic animal biology. So that happens. It's just unfortunate when a mutation occurs in a particular gene in a particular spot that it has dire consequences. Unfortunately, nature doesn't care about that because there are so many organisms, and if for the benefit of improving, biological diversity has no heart. It's a machine. You want to, exploit those environments. You have to have mutation.
All right.
Maybe there's environmental impacts that certain environmental insults can drive a mutation. UV, radiation, that contributes to it, and that's part of it. But it's also the part of being an animal or a plant. Really.
So it's not, because I worked a lot with radiation in my early career, taking lots of x-rays, and, I now have a child with a genetic mutation. I'm just wondering when people have looked at, we learned that, exposure to radiation can cause genetic mutations. Is there any retrospective study looking at people who've had children with these genetic mutations, and is there common things that they have done?
There's a little bit more work that I'm familiar at least with in the autism world, looking at maternal age, paternal age, various exposures and things like that. And I think Ingrid alluded to the fact that paternal age was thought to be one of the risk factors at one point, and still maybe for some conditions. But I think, and I would echo what Steve was saying, was just that we didn't really appreciate this as a field, and this wasn't so appreciated in genomics until the Human Genome Project was completed, and lots of people started getting sequenced. So there's a normal sequence now for every one of the genes we have. And so what is normal? It's a compilation of a few, probably graduate students and people who were in the labs who stuck up their sequence as normal, but we also now have it all annotated, and there's just tons of variability across us, and that just occurs spontaneously. And if it's random changes that happen, we all have thousands of them. If they're random changes that happen in places that don't really matter so much, we don't see any effects. It's truly the bad luck that a particular change happens in a particular spot that happens to cause a protein to change that leads to most of these conditions. So by and large, that's what's going on.
All right, we have a question up there.
Hi, my question was for Professor Annapurna about a comment you made this earlier on. Just you said that the CDKL5 treatment needed more finesse. I just wanted you to elaborate.
I meant my slide needed more finesse.
I'm glad you clarified.
Thank you.
I know
I
we
haven't
have
included that. We do have a CDKL5 center, and there's an NIH program to do that, and there are clinical trials on the way, but I'm not running them. One of my trainees is.
All right, we
There's
have
a trial shortly on CDKL5 starting in Australia, potentially.
All right, very good information. We have a question there, and then did you have something you were?
I was just going to say something funny about a salient story about analysis of genome sequences. My daughter had her genome sequenced recently and then sent it to a company to get an analysis of risk, and she apparently has a 6% chance of getting prostate cancer. Just be very careful about what people tell you.
Okay, yes, go right ahead.
My question is probably to Ingrid. Is being from another state in South Australia, what is being done or how collegiate are the neurologists, paediatric neurologists across Australia? We're seeing the scientists here working together to get into your research. Nothing is ever talked to us about doing that. We're not encouraged to actually seek genetic research. We know of families that have been told if we look to go to Ingrid, then we will not have neurology services back in South Australia, we'll be kicked off. So we are feel very isolated in just 8 hours drive away. It feels like a third world country sometimes in our medical, but trying to get the neurologists to work together to actually just nominate refractory children to actually be able to be a part of this research. My journey's 12 years on with 2 children, and I'm just reaching out now to become a part of your studies with a very long family history that hasn't happened. So that's my question. How are the neurologists across Australia? Because I'm sure WA have some issues too. We've heard lots of parents. And yeah.
So that's a tough...
And geneticists too. Because I've obviously had some genetic testing done for myself because the budget at the Children's Hospital is not good. So how are the geneticists communicating to you and your research teams as well?
Okay, so I'm going to split that into 2 questions. I think that my first answer was going to be a fairly glib, the child neurologists get on very well. And they do. In general, the child neurologists are a lovely community in Australia. And as I mentioned before, we have referrals from all over Australia. I have to say Queensland's been fantastic over a long time. Tasmania...
It's all Glenn.
Yeah, it must be you. Tasmania, we work very closely with the child neurologists down there, and the families down there have been great. There has been a little bit of resistance, and I think there's been lack of resources and access to testing in WA and South Australia. New South Wales has got a lot of momentum in its own right now, which is wonderful, and we've worked very closely with Deepak Gill up there and some of the other guys. One of the good things is the second issue, so I think it's better, we're very keen to recruit anyone. So, from our point of view, just as a research referral, which is different to a clinical referral, anybody's welcome. We'd love the more the merrier, and the more we can help, that's the aim of our game. And as you know, if you get a gene, it helps. The second huge issue, though, is funding, and we have a completely different model to the American model, but there has been no access to genetic testing, basically, until recently, and now it's come out in a very disparate way, so that if you're in Queensland, you can order a $7,000 panel of genes tomorrow. If you're Ingrid Sheffer, I can't order a gene. So it's all through my research program. The good news is that the NHMRC funded a $25 million genetic project really called Australian Genomics Health Alliance, but they've shortened it to Australian Genomics. And through that, I'm leading a flagship with somebody from every state, where patients have to have an epileptic encephalopathy, and they have to be referred and have to have been seen since 2016 by the neurologist referring. So if you've got an older child, you've got to see a new neurologist to get into it. That's just the way it's been set up. The reason for this is really to try and get exome sequencing towards Medicare. I mean, an MRI is on Medicare, exome sequencing should be on Medicare, but unfortunately Medicare is not at that place. It's clear that it should be the way, but we have to prove it. So we're currently going through a lot of work, a huge amount of work, to just prove that exome sequencing is cost effective. And that study I showed you that came out in the last week or so with the 1 in 2,000 has a health economic analysis in it, but which shows it works, but you have to build a case. So at the moment, anyone around Australia can go to a new neurologist as long as you've only seen them since the 1st of January 2016 and they haven't had a panel. If you've had a panel, you're out because you have to be untested to get into this. But if you want an exome other ways, then it's worth going to our research program. We are just closing the door on a set of exomes to go to an international collaboration at Harvard, but we may yet get another year. I'm not sure about that. So it's been very uneven, and hopefully we can work together. The child neurologists are all lovely though, and it's just a matter of breaking down the barriers.
All right, we're going to pause right there because I know we're getting close on time. We have one more comment from Maggie, who's, again, a comment from our live audience on the live stream. Thanks to all who do the research. We have a 24-year-old daughter with Dravet. Thanks to Professor Ingrid Scheffer. So I think that we will leave our conversation here with these amazing scientific experts. I don't think there's any doubt that this is an appreciative parent audience, and I think that kind of spirit of collaboration has been fostered. So I just want to give everybody an opportunity to give them a big round of applause, and then I'll spend about 5 minutes. Please feel free. And as we wrap up, just thank you so much, Ingrid. I want to take a moment. I will not make it long, but I just want to thank you. We began this day by talking about rare. I'm talking about the black swans of Western Australia, and southeastern Australia. And I found another bird in my research, which is the peacock, the white peacock. The white peacock is absolutely divine. It's a gorgeous bird, and it's a genetic mutation. So our kids are rare, and they're beautiful. And they're beautiful right now. So as we work to go forward and to help them to be healthier, to help them to be happier, to help them to have richer lives, I think there's nobody here who wouldn't think that right now as we have them, they're beautiful. So we appreciate all that we've gotten from all of our scientists in terms of helping us to take those next steps that we need to take, because we love them and we want them as they are. We just want to get them healthier and happier and to have better and richer lives. So for all of you, you took a pilgrimage today. You made time, you got babysitters, you cleared the decks, you didn't do a lot of fun things that you could have done that would have been lighter and easier, and you took time. And I think you proved what we know at GETA, which is that we care as parents. We want to know what the latest research is. We want to know what's happening. We're involved, we're motivated, and the smarter we are, the more we know, the more we connect with each other, with the scientists, with the researchers, with the companies, the better we do. I do want to say thank you, again, because this is possible because of Medibank, because of Praxis and RajCon, because of SCN2A families, because of Clockwork, because of the Epilepsy Foundation, because of KCNQ2 Cure, but most of all, those are great, and we really appreciate every penny that they gave us and all the time. But we really appreciate all of you. So thank you for coming. We have one housekeeping detail, and it's easy. It's pretty much what you tell your kids. We need to leave the theater clean. All right? So we tell that to our kids all the time. So don't leave your pens, don't leave your bags. Thank you. Keep in touch with us on GETA, and we appreciate all of you. Thank you. Have a great day.